How you doing? Here we are in Algebra 2, Section 6.1, and we are graphing quadratic functions. Let's take a look at our vocabulary today. When we refer to the concept of a quadratic function, we're thinking about a function that's in this form, y equals ax squared plus bx plus c, or this form, y is equal to a times x minus h quantity squared plus k. So for the most part, these are the two functions that we'll talk about, or the two forms of the quadratic function that we'll discuss. If you notice, this term right here has an x to the square power, has an x to the second power, and if I were to FOIL this out, I would end up with x to the second power after FOILing all of this information out here. So what is distinctive about a quadratic function is that we have an x squared term. The quadratic term, as you might have guessed, is that term right here. It's the x squared term. There we go. So in red, we see that that is the quadratic term. The linear term, as you might expect, is the term that is just x. Now, if we go back and we think about linear equations, we'll see that the linear equation is generally has an x term to the first power. And so we can keep that in mind when we think about the x term here, and we can call that as the linear term. Finally, we've got this guy called the constant term. Let's see if I can get my pen to write. The constant term right here is the term that's hanging out by itself. There's no, it's not a coefficient. It doesn't have a variable or an x next to it. It's usually just a number, 2, -5, something like that. Now the key here is when we have this graph, this quadratic function or this quadratic function, the graph of it, I said this graph, but when we have this function, the graph of it will be a parabola. So when I graph a quadratic function, we can have a parabola, which is kind of a U-shaped figure that can look like that, can look like this, can look like this. All of these are examples of parabolas, and that's what we get when we graph any function of the form of any quadratic function in this form. So let's focus on this equation, this quadratic function first, and let's look at these parabolas and think about them in terms of the next bits of information I'm going to talk about. So we know what a parabola is. It's this green shape here. Axis of symmetry. Symmetry means things being the same thing on either side, and so the axis of symmetry for a parabola is the line that cuts right down the middle. So both of these are axes of symmetry. I'm trying to draw it straight, my friends. I apologize. So these are axes of symmetry for each of these parabolas. And the next concept that we have is the vertex. Now the vertex is just like in geometry. The vertex is the corner point or the bending point. Sometimes I say here the vertex is this bending point of our parabola. So that's going to be our vertex. And then we can have a maximum or a minimum value. Now, in a parabola, if it is, I'm going to call this a sad parabola because it's upside down. If I have a sad parabola, it has a maximum value and it's reached here at the vertex. So this guy has a max at the vertex. And this one has, hopefully you figured it out, a minimum at the vertex. Okay, and so we can have only one max, or well, each of our parabolas can only have a max or a minimum. They can't have both. And so hopefully that clarifies some of the terminology that we're about to use in our lesson. Let's begin some examples. Here in example 1, we're asked to graph f of x is equal to 2x squared minus 8x plus 9 by making a table of values. First off, I want you to know that anytime you're asked to graph something, you can always make a table of values. You remember it back in the day, an XY table. Here I'm going to call it an x f of x table. And you're going to just choose x values at random. And sometimes this is the complicated part because you want to choose really good x values and you're not sure which ones to choose. But you can always start. Let's go ahead and start with like a -1, a 0, 1, 2, and 3 and see what happens. Now, we know that this graph is going to be a parabola. We recognize that it's going to have a U shape, either an upward U shape or a downward U shape. We haven't determined which one yet. So we know that one of these situations is going to happen. So one of the things I need to think about is there is going to be a repetition, if that makes sense, in terms of the y values. So if I had an x value here, this y value and an x value over here, this y value would be the same, and that happens on either side. And it would happen no matter where your parabola was located. So if my parabola is here, and I have this x value here, and this x value has a same y value as this x value. So in a way, you're always looking for what I'm going to call repetition in the x and the y values to know that you've met the corner point, you've curved around. Let's see how that works in this problem. So I rewrite the problem, leaving blanks for x and plugging in the x value. So I'll put a -1 here and a -1 here. Do the calculation, and I get that 2 times 1 minus, well, actually plus, because that's a negative times a negative, plus another 9 is going to end up giving me 2 plus 8 is 10 plus 9 is 19. And so I'll do it again for the next value, which is 0. Plug 0 in to both of these places. I love plugging in 0 because everything works out real nicely. Everything just goes away, and I get 9. And I'm going to keep doing this for each of the values of x. So I put a 1 here and a 1 here, and my calculation tells me that I get 2 minus 8 plus 9, which turns out to be 3. Again, I can continue by literally just dropping those x values right into the equation and coming up with my calculated answer. So over here, 2 squared is 4 times 2 is 8 minus 16 plus 9 is going to end up giving me a -8 plus 9, which is a +1. And I'll do it over here one last time. Hopefully something good will happen. I get a 9 here times 2 is 18 minus 24 plus 9. With these two terms, I get a -6 plus 9 gives me a +3. Do you see what happened? There's repetition that's gone on here. And if you want to confirm that we've reached the bottom of our parabola and we're coming back up, I should expect, I will put this in a different color, that this would be 9 when I plug it in, because that's the symmetry that's being at play here. So let's see. I rewrite my function. I place 4 into it. 4 squared is 16 times 2 is 32 minus 32, that's 8 times 4, plus 9. I think you guys see it. I get a 9 over here. And so I am absolutely correct, and this is enough to graph my parabola. There's a benefit in creating your table before you start drawing your XY axes to graph, and the benefit is that I know where I need to put my numbers. So notice my x-axis only goes from -1 to +5, so it incorporates the values that I've used here, and my y-axis goes almost up to 19. I wasn't really pressed about putting that 19 in my graph, so I wasn't concerned. I got up to 16, which was good enough for me. All right, let's get started graphing. So at -1, I'm all the way up at 19, which would be about somewhere here. And at 0, I'm at 9, which would be between 8 and 10. At 1, I'm at 3, which is between 2 and 4. At 2, I'm back up to 9. And, oh no, at 2, I'm at 1, my bad. At 3, I'm at 3, and at 4, I'm back up to 9. Sorry about that. I got a little overexcited. And then so you can see this beautiful parabola that's going to happen here. And you know I can't draw as easily as I'd like to in this particular program, but I hope you can see that this is not a V shape, it is a U shape. Let's go ahead and see if we can do a couple more problems. A little bit quicker though. In order to graph a parabola faster, so we've reached, before we start our next example, we've reached one of these pages where we get to consider some key concepts. And what I'd like you to recognize is that whenever you have an equation of this form, right, this is our quadratic equation or our quadratic function, the y-intercept is always going to be c. Remember, the y-intercept is the value of y when x is equal to 0. So if I put 0 in for x, what comes out is this last term, this c value. So the y-intercept is always c, as you see in the graph down here. The equation of the axis of symmetry, this is so important, is going to be x is equal to -b over 2a. All right? So what this is saying is, if I want to know what the equation of that line is that runs straight down the center of my parabola, all I have to do is see the equation and I can say, oh, the opposite of b over 2 times a, negative b over 2a. This is going to be so super helpful for us. The x-coordinate of the vertex is going to be negative b over 2a, which makes sense. If this is the axis of symmetry, and the axis of symmetry is some value negative b over 2a, then we know that the x term here is whatever that number is, negative b over 2a, and therefore the x-coordinate of the vertex is going to be negative b over 2a. To find the y-coordinate, sometimes we use the symbol f of negative b over 2a, which is just a fancy way of saying plug negative b over 2a into the original equation for x and figure out the y value. Now that we know how to find the vertex, the axis of symmetry, the y-intercept, I think we're ready to start this next problem. So in example 2, the axis of symmetry, y-intercept, and vertex, we're going to find all of those things about this particular function. So it says find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. We got this. Very simple. First thing, I think it's really worth rewriting this function, writing this quadratic function in the typical standard way. So we're going to have the x squared term first, the linear term next, that's 8x plus 9. And so now let's go ahead and answer the question. Find the y-intercept. The y-intercept is going to be the 9, right? Remember, y-intercept is c from our little picture up here. It told us the y-intercept is going to be the c value, the number that's left alone. So what we'll do is we call the y-intercept is 9. When I write the y-intercept, I like to write it as a point. So it's 0, 9. That's the y-intercept, and that was pretty easy to get. The next thing we're going to talk about is the equation of the axis of symmetry. The axis of symmetry, sometimes I write it as A of S, axis of symmetry, is given as x is equal to negative b over 2a. Negative b over 2a. So how do we deal with that? We'd say x is equal to, what's our b term over here? It's 8. So negative 8 over 2 times a, our a term is 1. So negative 8 over 2 times 1 gives me negative 8 over 2, sorry about that crooked looking 8, which is negative 4. So our axis of symmetry is x equals negative 4. It's actually an equation. It's an equation of a vertical line, all right? And the final thing we need to do is find the vertex. So the vertex, I told you, let's do this here. The vertex I mentioned is going to be a point where the first term is negative b over 2a and the second term is f of negative b over 2a. Negative b over 2a. Let me write that there, and negative b over 2a here. Well, we know negative b over 2a is negative 4, so I know the vertex is negative 4, and what I need to do is plug negative 4 into the equation in order to figure out the corresponding y term of the vertex. So I'm going to put negative 4 in there. So watch this. F of negative 4 is equal to negative 4 squared, you know I'm just putting it in here, right, plus 8 times negative 4 plus 9. Negative 4 squared is 16 plus 8 times 4 is a negative 32 plus 9 is what we've got to do. These guys come together to give me a negative 16 plus 9 gives me a negative 7. So I get that my point is negative 4 comma negative 7. So the next thing we're going to do is make this table of values including the vertex. Now the smart money is on starting with your vertex right in the center of your table of values, because if you think about it, your vertex is going to be that curve point. Let me draw a little diagram. So you know that what happens on one side of your vertex is going to happen on the other. So we're going to cheat a little bit, right? We're going to try to do as little work as possible. And so here's what I'm thinking we'll do. We're going to choose values on either side of negative 4 so that it's easy for us to do work. So I'm going to go like negative 3 and negative 2. And then on this side we'd have negative 5 and negative 6. Okay, so recognizing I've got to plug these values in, I'm going to do just that. Throw a negative 3 here, a negative 3 here. I get a positive 9 plus equals, okay, so I get a positive 9 minus 24 plus 9. And when I'm finished with that, I get a negative 6. So I have a negative 6 here. And if I get a negative 6 there, I know I have a negative 6 here. Let's do this last one. If I put a negative 2 in here and here, I get a positive 4 minus 16 plus 9, which is going to give me negative 12 plus 9, which is going to give me a negative 3 here and here. We're going to use this information to graph in just a moment. When we plot the points from our t-table, we should get this shape, this kind of a graph. This video will continue in the part 2 section where we'll finish off this